In this video, we will understand logic gates and circuits. Logic gates is a basic building block of a digital circuit that has two inputs and one output. The relationship between the input and the output is based on a certain logic. These gates are implemented using electronic switches like transistors, diodes. Types of logic gate. There are various types of logic gate as follows: AND, OR, inverter or not, NAND, NOR, exclusive, OR. Let's understand these types of logic gate in detail. AND gate. This gate is also represented by dot like A dot B. In AND gate, it returns true only if both the conditions or inputs are true, otherwise it returns false. Let's understand this by using a truth table, where A and B are inputs and X is output. Therefore, X is equal to A and B. This truth table represents the behavior of AND gate in digital logic. The AND gate is a basic logic gate that operates based on the following rule. It outputs a 1, that is true, only if both inputs are 1, otherwise it outputs a 2, that is false. Let's say A is 0 and B is also 0. Since both inputs A and B are 0, that is false, the AND operation results in 0, that is false. Let's take another situation. A is 0 and B is 1. Here, one of the inputs is 0 and the other is 1, so the AND operation results in 0, that is false. Let's take one more situation. A is 1 and B is 0. Here, one of the inputs is 0 and the other is 1. So the AND operation results in 0. That is false. One more situation is there. A is 1 and B is also 1. Both inputs are 1. So the AND operation results in 1. That is true. In short, the output X is 1 only when both A and B are 1. Otherwise, the output is 0. Next is OR gate. This is represented by plus like A plus B. It returns true if any one of the conditions or inputs is true, and if both conditions are false, then it returns false. Let's understand this by using a truth table, where A and B are inputs and X is output. Therefore, X is equal to A plus B. Let's say A is 0 and B is also 0. Since both inputs A and B are 0, the OR operation results in 0. That is false. Let's take another situation. A is 0 and B is 1. Here, one of the inputs is 1, so the OR operation results in 1. That is true. Let's take one more situation. A is 1 and B is 0. Here, one of the inputs is 1, so the OR operation results in 1. That is true. One more situation can be there. A is 1 and B is also 1. Both inputs are 1, so the OR operation results in 1. That is true. So the output is 1 if either or both of the inputs are 1. The only time the output is 0 is when both inputs are 0. Inverter or NOT gate. This gate is also represented by dash like A dash. In NOT gate, it returns true if input is false and vice versa. Let's understand this by using a truth table, where A is input and X is output. Therefore, X is equal to A dash. Let's say A is 0. Here the input A is 0 and the output X is the negation of A, which is 1. Let's say A is 1. Here the input A is 1 and the output X is the negation of A, which is 0. So the NOT gate inverts the value of input. NAND gate. It is basically the inverse of the AND gate. This gate is designed by combining the AND and NOT gates. It returns false only if the both conditions or inputs are true. Otherwise, it returns true. Let's understand this NAND gate by using truth table, where A and B are inputs and X is output. where output X is represented by A dot B whole bar or A bar plus B bar. Let's say both the inputs A and B are 0. So the AND operation on A and B results in 0. But the NAND gate inverts this result, producing 1. Let's take another situation where A is 0 and B is 1. So the AND operation on A and B results in 0, and the NAND gate inverts this to produce 1. If A is 1 and B is 0, the AND operation on A and B results in 0, and the NAND gate inverts this to produce 1. And if both the inputs A and B are 1. So the AND operation on A and B results in 1, but the NAND gate inverts this, producing 0. In short, NAND gate is the opposite of AND gate. It produces 0 only when both inputs are 1. NOR gate. It is an inverse of an OR gate. This gate is designed by combining the OR and NOT gates. It returns true only if both the conditions or inputs are false, otherwise it returns false. Let's understand this NOR gate by using truth table, where A and B are inputs and X is output, where output X is represented by A plus B whole bar or A bar dot B bar. Let's say both the inputs A and B are 0. So the OR operation on A and B results in 0, but the NOR gate inverts this result, giving an output of 1. Let's take another situation where A is 0 and B is 1. So the OR operation on A and B results in 1, but the NOR gate inverts this result, giving an output of 0. If A is 1 and B is 0, the OR operation on A and B results in 1, but the NOR gate inverts this result, giving an output of 0. And if both the inputs A and B are 1, the OR operation on A and B results in 1, but the NOR gate inverts this result, giving an output of 0. So, NOR gate will output 1 only when both inputs are 0. In all other cases, the output is 0. Exclusive OR gate or XOR gate, it performs based on the operation of OR gate. It returns true only if one condition is true from both the conditions, otherwise it returns false. Let's understand this by using truth table, where A and B are inputs and X is output, where output X is represented by A XOR B or A bar B plus AB bar. Let's say both the inputs A and B are 0. So the output is 0 because both the inputs are same. Let's take another situation where A is 0 and B is 1. So in this situation, only one input is true. So the output is true, that is 1. If A is 1 and B is 0. Similar to earlier situation, here the output is 1 because only one input is 1. And if both the inputs are 1, that is same, then the output is 0, that is false. So in XOR gate, output is 1 when only one of the inputs is 1. But it outputs 0 when the inputs are either both 0 or 1. Let's practice some questions of logic gates and circuits. Question 1. Which of the following gates returns true if both inputs are true? Options are OR and not XOR, NAND. Correct answer option is B, AND gate. Because AND gate returns true only when both inputs are true. Other gates or not XOR, NAND do not return true when both inputs are true. Question 2. What is the output of a NOT gate if the input is 1? Options are 0, 1, undefined, both 0 and 1, no output. Correct answer option is A, 0, because a NOT gate inverts the input. So if the input is 1, the output will be 0. The NOT gate always returns the opposite of the input. Question 3. Which of the following gates is called a universal gate? Options are AND, OR, NAND, XOR, NOT. Correct answer option is C, NAND, because the NAND gate is considered a universal gate because it can be used to implement any other logic gate. Other gates like AND, OR, and NOT cannot perform all logical operations on their own. Question 4. Which of the following gates returns true when at least one input is true? Options are AND, OR, XOR, NAND, NOT. Correct answer option is B, OR, because an OR gate returns true if at least one of the inputs is true. The AND gate requires both inputs to be true for an output of 1. Question 5. What is the output of an OR gate when both inputs are 0? Options are 0, 1, undefined, both 0 and 1, none of the above. Correct answer option is A, 0, because an OR gate returns 1 if any input is 1, but if both inputs are 0, it returns 0. The only time an OR gate outputs 0 is when both inputs are 0. Question 6. Which logic gate is represented by the symbol A dash? Options are OR, XOR, and NOT, NOR. Correct answer option is D, NOT gate, because a dash represents the NOT gate, which inverts the input value. Other gates do not use the A dash. Question 7. For an XOR gate, what is the output when A is 1 and B is 1? Options are 1, 0, undefined, 2, no output. Correct answer option is B, 0, because for an XOR gate, the output is 1 when the inputs are different. When both inputs are the same, the output is 0. XOR outputs 1 only for differing inputs. Question 8. Which logic gate gives an output of 1 only if both inputs are different? Options are AND, OR, XOR, NAND, NOR. Correct answer option is C, XOR gate, because an XOR gate returns 1 only when the inputs are different. Other gates like AND or OR return true when both inputs are the same. Question 9. Which gate performs the opposite function of the AND gate? Options are NOR, XOR, NAND, or NOT. Correct answer option is C, NAND gate, because a NAND gate performs the opposite function of an AND gate. It returns the inverse of the AND operation. The NOR gate performs the opposite of OR, not AND. Question 10. Which of the following is the truth table for a NOR gate? Options are 110, 001, 000, 100, 101. Correct answer option is C, 000, because a NOR gate returns 1 only if both inputs are 0. If either or both inputs are 1, it returns 0. Other options do not correctly reflect the NOR gate truth table. Question 11. What will be the output of a NAND gate when both inputs are 1? Options are 1, 0, undefined, 2, no output. Correct answer option is A, 1, because a NAND gate returns 1 unless both inputs are 1, in which case it returns 0. So if both inputs are 1, the output is 1. Other options are incorrect for this scenario. Question 12. Which of the following gates gives an output of 1 only if both inputs are false? Options are AND, OR, XOR, NOR, NAND. Correct answer option is D, NOR gate. Because a NOR gate returns 1 only if both inputs are false. It is the opposite of the OR gate, which returns 1 if any input is true. Other gates do not give an output of 1 only when both inputs are false. Question 13. Which gate's truth table is exactly the opposite of an OR gate? Options are AND, XOR, NOR, NAND, NOT. Correct answer option is C, NOR gate. Because the truth table of a NOR gate is the opposite of an OR gate. While an OR gate returns 1 when at least one input is 1, a NOR gate returns 1 only when both inputs are 0. Other options do not provide the opposite of the OR gate's behavior. Question 14. What is the output of an AND gate when one input is 0 and the other is 1? Options are 1, 0, undefined, 2, both 0 and 1. Correct answer option is B, 0. Because an AND gate returns 1 only if both inputs are 1. If one input is 0, the output will be 0. The other options are incorrect based on the AND gate's truth table. Question 15. Which gate is the inverse of the XOR gate? Options are AND, OR, NAND, NOR, XNOR. Correct answer option is E, XNOR gate. Because the XNOR gate is the inverse of the XOR gate, meaning it returns 1 when the inputs are the same, both 0 or both 1. Other gates do not perform the opposite function of XOR. Question 16. If A is 1, B is 0, what is the output of an AND gate? Options are 1, 0, undefined. Both 0 and 1, no output. Correct answer option is B, 0. Because an AND gate returns 1 only when both inputs are 1. If one input is 0, the output will be 0. Other options are incorrect based on the AND gate's behavior. Question 17. What is the Boolean expression for a NAND gate with inputs A and B? Options are A plus B, A dot B, A dot B whole dash, A dash plus B dash, A dash dot B dash. Correct answer option is C, A dot B whole dash, because the Boolean expression for a NAND gate is the negation of the AND operation, which is represented as A dot B whole dash. Other expressions are not correct for a NAND gate. Question 18. Which gate is used to invert the result of an AND gate? Options are XOR, NOR, NAND, or NOT. Correct answer option is C, NAND gate. Because a NAND gate inverts the result of an AND gate. It performs the opposite of AND, returning 1 unless both inputs are 1. Other gates do not provide this inversion. Question 19. What is the output of the NOR gate when both inputs are 1? Options are 1, 0, undefined, both 0 and 1. No output. Correct answer option is A, 0. Because a NOR gate returns 0 if either of the inputs is 1. If both inputs are 1, it will return 0. Other options are incorrect as NOR only outputs 1 when both inputs are 0. Question 20. Which gate is used to perform logical addition between two inputs? Options are XOR, AND, OR, NOT, NAND. Correct answer option is C, OR gate. Because the OR gate performs logical addition, meaning it returns 1 if at least one input is 1. Other gates perform different logical operations.